In Quito, the ground stops, while he keeps moving east at 465 meters per second. For 1 second, stopped ground acts like a backward wall under people, cars, signs, roof tiles. Solid Earth stops rotating exactly 1 second, then restarts. Inertia does damage, with no shield. Quito sits almost on the equator, where Earth's rotation is fastest. Before the stop, every building there is already moving east with the planet, silently. When the crust halts, bolted things feel a violent load through their foundations. Loose things feel nothing from the ground until they smash into it in the first instant. The air above Quito was also moving east at 465 meters per second. When the ground stops, that air becomes a Mach 1.35 blast over the roofs. Glass, parked cars, umbrellas, and loose bricks shoot east, crossing several soccer fields in a second. A standing person has a worse problem. Their feet are slowed by pavement first, while their head and organs keep the original speed even before the air hits. Tall buildings get hit from inside and outside at once. Their frames stop with the crust, then wind and contents hammer them eastward like thrown furniture. At the coast, seawater keeps its old sideways motion. The shoreline stops underneath it, so spray, boats, and harbor cranes lurch east and slam across docks. There's no epicenter. Everywhere rotating stops together, and loose objects keep their earlier speed. For 1 second, Earth is the obstacle. The crash comes from the ground underneath. The speed map starts at the equator. In Quito, the ground is normally racing east at about 465 meters per second, faster than sound at sea level. That number comes from the planet's waistline. Earth spins once every 23 hours, 56 minutes, and 4 seconds, so the equator covers the most distance in one spin. Slide a little north to Nairobi, and the arrow barely shrinks. Nairobi sits near 1 degree south, so it keeps about 455 meters per second. The first body count follows that arrow. Near the equator, people, roofs, cars, and loose soil keep moving east when the ground quits. Now climb to New York, around 41 degrees north. The ground there carries about 355 meters per second, still more than a passenger jet at cruise. London is farther up the curve, near 51.5 degrees north. Its eastward speed drops to about 288 meters per second. Reykjavik sits close to 64 degrees north, where the circle around Earth is much smaller. The sideways shove is about 204 meters per second. At the poles, the map almost goes quiet. You still turn in place once per day, but your sideways ground speed on the map is nearly zero. Every arrow points east because Earth rotates eastward. During the stop, buildings lose that push instantly, while everything loose above the ground still has it. Latitude quickly matters. Red near the equator, fading north to pale blue over the Arctic. Height adds only a tiny amount, because even Everest is small beside Earth's radius. Latitude is the number that matters in the first collision. After that second, the equator has maximum crash speed. The Arctic is the first safer zone. Take Dubai, 25 degrees north, where before the stop, the ground, roads, and every tower are moving east at about 920 miles per hour. That includes windows, elevators, and bodies. The Burj Khalifa's foundation is locked to the crust, so its base hits the brake first. More than 160 upper floors keep sliding east for about a heartbeat. Half-mile steel columns take sideways loads. Elevators, tanks, panels, and people hit gravity-built bolts. Taipei 101 sits at almost the same latitude as Dubai. Its 660-ton tuned mass damper is built for typhoons and earthquakes, then gets overwhelmed. Road decks are bolted to piers in short segments with bearings underneath. When the piers stop, the slabs shove east and peel loose. Cars have no anchor to bedrock. Tires lose their quiet grip, and traffic becomes a pack of metal boxes with drivers inside flying sideways down the lanes. Rail tracks are continuous steel ribbons clipped to sleepers. A sudden shove kinks them sideways, snapping joints and tossing trains off straight lines. Buried pipelines seem safer until the soil stops unevenly. Long pipes tear at elbows, valves, and building entrances under streets that are cracking, then leaking gas finds sparks. Power towers are tall tripods holding tensioned wire. The towers break with the ground, while cables whip east and yank the next tower down. Inside apartments, the walls change speed before the rooms do. Glass fronts burst outward, desks skate sideways, and stairwells turn into hard chutes. In Sao Paulo, you're moving east around 950 miles per hour. Then the floor stops. Before air or ocean really matter, towers, rails, pipes, and traffic have already shredded the city. Now, the sky joins in. At the equator, the air still carries about 465 meters per second eastward, while the ground beneath it has frozen. That's faster than sound at sea level. For anyone on the surface, the first weather report is a wall of air arriving sideways. Warm sea level air gives dynamic pressure, half density times speed squared, about 130,000 pascals. That's about 19 pounds per square inch on anything facing the blast, including garage doors. Windows fail first, then frames and roofs follow. Once a roof edge lifts, pressure underneath helps unzip the building from inside. Forests take the same hit across millions of leaves. Branches become drag handles, and loose bark joins the moving grit before trunks give way. Sand, glass, roof gravel, and street signs accelerate almost instantly. At these speeds, a bottle cap can strike like shrapnel from a shell. The air piles against hills before it can climb them. Pressure spikes on the windward side, while the lee side fills with ripping turbulence. The Andes become a continent-length ramp for this moving atmosphere. Air slams upward, cools violently, and throws shockwaves into thinner layers above. Across Asia, the Himalayas do the same job with taller teeth. Valleys funnel the flow, so sheltered towns get squeezed by their own geography. In East Africa, highlands interrupt air, moving faster than a rifle bullet's crack. The ground has stopped, yet the atmosphere is still crossing borders. So, oceans aren't required first. Earth makes a 1-second sideways blast around the equator. And the cruel part is timing. Before Earth starts spinning again, the air has already turned weather into impact physics at street level. Then, the missing second ends. At the equator, the ground tries to regain about 465 meters per second of eastward speed instantly. Anything still gliding with its old speed suddenly matches the surface again. For that lucky debris, the sideways violence briefly cancels. Most things aren't that lucky. Tires, walls, soil, and collisions have already stolen speed from people, cars, trains, and whole buildings. Now the planet pulls the floor east underneath them. To a survivor on pavement, the wreckage seems to skid back the other way. A bus that slammed into a building during the stop may get pinned. When rotation returns, the street tries to rip its underside east. Rails do something uglier. A train slowed by friction feels the track accelerate under its wheels, forcing a second sideways grind along the line. Runways become giant conveyor belts. Aircraft wrecks and fuel trucks that survive the first shove get dragged across concrete in the reverse relative direction. Inside collapsed structures, the second shove is brutal. Floors tied to the crust move east, while loose slabs and furniture lag behind. Bridges take a nasty torsion hit. Their foundations obey the returning planet, while suspended sections loaded with traffic resist for a fraction longer. The air near the ground changes again too. The worst surface wind drops where air kept its old eastward speed, then chaos fills the gap. Dust, glass, and roof panels don't politely settle. The returning ground punches fresh turbulence into streets already packed with flying wreckage. Away from the equator, the restart is smaller because spin speed depends on latitude. London gets about 288 meters per second, still rifle bullet territory. So, the 1-second stop has two impacts, one when the crust halts and one when it returns. The ocean is still late. At the equator, the seabed stops, and the water above still carries about 465 meters per second sideways. For 1 second, they disagree violently. That is almost 5 football fields of sideways slide before the restart even joins in. The seafloor has become a fixed obstacle under moving water. Continental shelves make it uglier. Shallow water feels the stopped floor harder, so the moving ocean buckles upward and forward in long rows. In the Atlantic, the bulk shove points toward Europe and West Africa. Coastlines that faced west now receive a basin-sized body check. Portugal, Morocco, Senegal, and the Gulf of Guinea don't see one neat wave. They see confused water stacked by bays and headlands. Across the Pacific, the shove aims at the Americas. The first brutal lift would favor Ecuador, Peru, Central America, and western Mexico. Islands complicate the map. Hawaii, Samoa, and thousands of reefs become speed bumps that split the surge into crossing trains of water. In the Indian Ocean, water piles towards Southeast Asia and Western Australia. Indonesia sits in a messy doorway between whole basins. The second Earth starts spinning again. The bottom grabs eastward, under water that hasn't caught up. Now the slosh gets a second kick. Waves reflect off continental slopes, shelves, and closed seas. Inside a few harbors, the water rings like a bowl slapped on a table. The worst places would be shallow funnels, like river mouths and long bays. A few extra meters offshore can turn into streets full of seawater. The stop lasts 1 second. The ocean's answer lasts hours, because a planet-sized bathtub keeps rocking after the hand is gone. After the water comes the count. The safest names on the map are near the poles, where ground speed was already close to walking speed. At the South Pole itself, a station could feel a violent world event as a shove, alarms, and maybe a building groaning in the wind. A few hundred kilometers away, the danger rises fast. Latitude decides your sideways speed before the oceans and atmosphere even join the damage. Near Quito, Nairobi, Singapore, and Manaus, the surface had been moving about 465 meters per second. That is rifle bullet speed across streets. Near the equator, buildings fail sideways, vehicles turn loose, and survivors face wind, debris, returning water. High latitudes get a different report. Reykjavik, Anchorage, and Ushuaia still suffer storms and surges, with far less inherited sideways motion. Orbit is strangely calm above all this. Satellites keep falling around Earth at kilometers per second, barely caring that the ground stuttered below. GPS and weather satellites would see chaos on the surface. Their tracks stay basically orbital, because space was never bolted to the crust. The clocks get the cleanest scar. One rotation took 1 second longer, so that day is written as 24 hours and 1 extra second. Earth's shape does almost nothing dramatic in 1 second. Losing spin removes only about 0.34% of apparent weight at the equator. That tiny weight change cannot pull the planet into a new ball. Rock and ocean answer to millions of years, far more than one missing tick. Put one stickman at the South Pole, and he barely slides. Put another at the equator, and his whole horizon becomes a skid mark. After 1 second, Earth spins again, sky normal, but former speed scraped 40,000 kilometers.